Hello and welcome to Microsoft on AWS Modernization Series Part 2 Monolith to Microservices. As we progress through this video series, we will center on a fictional company, Acme Financial Data Services, AFDS, to demonstrate key modernization practices. The practices here have been performed on actual companies and have been reproduced here and applied to Acme Financial Data Services. So where is AFDS in their journey? Well, so far in phase 1, they have completed a lift and shift to AWS using standard practices like Cloud Endure and have pretty much what they had on-prem in the cloud. In phase 2, they performed a series of optimization efforts on their AWS infrastructure. This was also covered in an earlier video series, Windows on AWS optimization series. So what now? Well, as part of phase 3, we're going to be talking about modernization of legacy applications to maximize the benefits of being in the cloud. So what is it that we're going to modernize? Well, AFDS has a platform called OneVision, and you are tasked with assisting Acme Financial Data Services to modernize their OneVision platform. This represents a legacy monolithic application which is now on AWS, but is pretty much as it was when it was on-prem. It is used to manage customer accounts, customer invoices, and inventory associated with the above. So the question now is, why modernize? Well, uncovered in video 1, which was why modernize, we talked about migrating large legacy applications to the cloud, centering around operational costs, i.e. the costs associated with running that infrastructure and how you can save or how to focus on where you can make savings. Workforce productivity, how effectively are you able to get your services to market, i.e. as market changes are implemented or you want to respond to market changes, how can you effectively respond to those changes? Cost avoidance, i.e. the creation of an environment that doesn't create unnecessary costs. Have you trimmed the fat of your, say for example, on-prem infrastructure when you migrated it to AWS in a lift and shift effort, and being able to run the most cost optimized infrastructure as you did the optimization effort? Operational resilience, the reduction of your organization's risk profile and risk of migration and mitigation. For example, are you using the best of the cloud with regard to failover, high HA, and disaster recovery? Business agility, the ability to react quickly to changing market conditions. Is your infrastructure and the way you have organized your infrastructure allow you to respond to market changes? Time to value, the opportunity cost of delaying migration for re-architecture or refactoring activities. The modernization journey, and we will break it down with regard to monolithic and microservices. For example, monolithic, as you will know, having done this for many years, it makes deployment simple. It's just one large bunch of code that is deployed, and there are typically binary failure modes. So for example, if you have 10 services inside your monolithic application, the thing is that if one service fails, everything has to fail as well. So there is little failure options. Intermodule refactoring. So for example, if you have to change one service, potentially that could impact another service or another service beyond that. So there's a lot of coupling that you have to worry about. You also have a technology monoculture. What does that mean? Effectively, what that means is the database, or for example, the application, has to be written in a single language, C#, Python, and everybody has to work and adhere to that single technology. Restricted scaling. For example, there's a service like invoicing or accounting that you need to be able to scale if there's additional demand or load, then you have to scale as a whole as opposed to being able to scale a single service horizontally. It is more challenging deploying microservices, but it allows you to then have partial deployment, so you can basically only deploy an upgrade or a change to a specific service rather than have to deploy as a whole. Also, you have the graceful degradation. So, for example, if a service fails, it should not impact other dependent services or other services that are as dependent as they were before. Also, you want to have strong module boundaries. This talks back to graceful degradation. So, for example, if one service is having some issues, it does not impact the application or platform as a whole. Technology diversity. By having microservices or using microservice practices, you can then use the most ideal technology or language or architecture for the microservice that is being developed or being refactored. Independent scalability. By having independent scalability, you're able to horizontally scale, load, launch additional microservices as you anticipate additional load on certain services without impacting or needing to have additional services that aren't needed to be scaled. Independent deployability is key. What does that mean? Independent deployability is the idea that we can make a change to a microservice and deploy it into production environment without having to utilize any other service. You also need to get into the habit of releasing changes to a single service into production without having to deploy anything else. And also, to guarantee independent deployability, we need to ensure our services are loosely coupled. In other words, we need to be able to change one service without having to change anything else. So the desire for a loosely coupled service with stable interfaces guides our thinking about how we find service boundaries in the first place. Next, let's talk about coupling and cohesion. First of all, we want to reduce coupling. Monolithic services can have quite high coupling. Tight coupling of unrelated services is bad. So, for example, in the case of monolithic services that might be coupled are hard to basically scale, like we said before, among other challenges. It is expensive to change code in applications which are tightly coupled, because one change to a service might need you to have to change a service which is unrelated, but the way it was written requires that change. And also multiple changes across unrelated services, as well as multi-deployment. So, for example, if you want to make an update to one service, you might end up having to redeploy 3 or 4 other services which have not changed, therefore increasing your chance of having issues when you move those changes into production. Cohesion. What we need to do is increase cohesion. What does that mean? Code that changes together stays together. Also, cohesion is how you group your code together. And what you will need to think about is bring together tightly related code. This moves on to the next statement by Martin Fowler. If you do a Big Bang rewrite, the only thing you're certain of is a Big Bang. So we need to think about this as we start to do our modernization journey. We have discussed key factors like coupling, cohesion, and independent deployability. Let's use this chart to guide where possible places to start modernizing are for AFDS. We will use this chart to ring fence possible services. Let's place them on the map based on where we feel they fit best. Also, make sure you work with both business sponsors and chief architects to populate this chart. The x-axis focuses on services which are easy to extract from the monolith. For example, they have lower dependencies and lower coupling. The y-axis will focus on services which provide the greatest benefit from both a business and or technical learning perspective. Having discussed with business sponsors and technical architects, we feel that shopping is relatively easy to extract, but the business benefit is low. But for the accounting service, we feel that it is both easy to extract, and the benefits of extracting it will also provide the greatest benefit. Payroll will be hard to extract, and the benefits of extracting it from both a business and architectural perspective are low. Inventory will be less easy to extract, but the benefits of extracting it will be great from a technical and business perspective. And finally, invoicing. We feel it will be both easy to extract as well as the benefits of extracting it for the business as well as for technical learning will also be high. Having assessed the business and technical drivers for AFDS, you have selected which services to modernize using the axis chart shown. The yellow box indicates services which have high cohesion and should all be considered in an initial phase of modernization. Prior to any modernization and architectural change, an organizational change within your company is key to ensuring success. Changes in functionality are primarily about changes in business functionality, and they should not be driven by technical drivers. But here our business functionality is in effect spread across all three tiers, thus increasing the chance that a change in functionality will also impact all the layers. This is an architecture in which we have high cohesion of related technology but low cohesion of business functionality. If we want to make it easier to make changes, instead, we need to change how we group code. We should choose cohesion of business. So here you can see the account service, the invoicing service, and the inventory service are actually crossing across three swim lanes, impacting the API team, the business logic team, and the data team. What does that mean? So in terms of typical monolithic ownership, organizations are broken down by technical competencies. Historically, teams are organized by technical competency and siloed. For example, all DBAs sit together, all UI developers sit together, and so on. Product sponsors are the spokesmen for the business and users. Therefore, each team implements what they believe is being requested by the product sponsor. Teams should be grouped based on business function, for example, accounts, inventory, invoicing, and closer to the business sponsor. So this example here shows users conveying their requests to the product sponsor. The user could be external users or it could be internal users, but key thing is that the requests are channeled through a product sponsor. Between a product sponsor and the actual development teams, you have what is sometimes referred to as the land of confusion. Therefore, the product sponsor will make his requests through the so-called land of confusion. Once it passes through there, it will then be conveyed in different understandings to the UI team, the app logic team, and the DBA team. So what you see here is the organizational structure is replicating the application structure. A key approach to developing microservices is to reorganize your team to align with services to meet the needs of the business rather than focus on technical limitations which are being placed on them. So as you see here, once you start breaking off services, you need to actually have dedicated API teams, business logic teams, and data teams dedicated to a particular account service, in this case team A. Likewise, for invoicing service, team B, you need to have a dedicated API team, a business logic team, and a data team. This is reflected here, where we have dedicated teams for the accounts, a dedicated team, so for example, retail, which is also responsible for the inventory service, an e-commerce team which is responsible for the shopping service. And as you can see here, each has its own dedicated API team, data team, and business logic team. To further augment this, you should have a dedicated product sponsor Therefore, there is no loss of communication in terms of interpreting what is being requested from the user. So therefore, by organizing teams into specific business-focused teams and having their own dedicated technical resource and each having direct access to the business sponsor, they can better respond to the ever-changing expectations of the business. Conway's law applies to modular software systems and states that any organization that designs a system, defined more broadly here than just information systems, will inevitably produce a design whose structure is a copy of the organization's communication structure. Let's start now by talking about modernization failure modes. Along with picking suitable candidates to modernize, AFDS need to understand modernization failure modes and make adjustments in the decision making and the desired end state to avoid some of these common pitfalls. Let's start with recreating old problems in newer ways. By changing historical approaches and mindsets and exploring the potential of the cloud, you can avoid recreating smaller monoliths. By ensuring you have explored a way to fully monitor all the new layers you are introducing and consolidating your logging and monitoring, you can avoid adding to troubleshooting nightmares. Also, by growing incrementally and carefully, you can avoid incrementally bloating operational burden. Misaligned organizational and cultural practices can be avoided by forming a cloud center of excellence and pooling your guidance and best practices through it, and then performing reorganizational changes into service teams. You can avoid large teams without clear ownership. By breaking the monolith, you can move away from big bang releases, as we discussed earlier in this video, and then also by assigning dedicated product sponsors to each service team, you can avoid disconnected customers. Theatrical innovation scheme. Again, by having a dedicated product sponsor, as well as forming a cloud center of excellence and pooling guidance and best practices through it, you can avoid siloed innovation teams and innovation drama with misaligned business values. Transformation fatigue and unclear business value. Again, by forming a cloud center of excellence and pooling guidance and best practices through it, you can avoid piped vision with business value and unclear and delayed business value realization. Again, by closer coordination with product sponsors and moving to a microservices delivery approach, you can avoid a multi-year wait and biting off more than can be chewed. Let's now talk about migration strategies. The following are some .NET application migration strategies. Let's take the source technology as ASP.NET Framework hosted on an IIS server. And this server is on-prem. Let's go through some activities and target architectures and target technologies that we have with regard to these migration strategies. For example, rehost. That can be done by rehosting onto an Amazon EC2 instance. The target technology would then be ASP.NET Framework hosted on IIS. This is almost a lift and shift type of approach. Next is replatform, where you could basically take the existing framework and just place it on to Amazon AWS Elastic Beanstalk, which would also be ASP.NET hosted on IIS. Next would be a potential replatform rewrite option, where we could leverage Amazon ECS, the container technology. The target technology would then be either a replatform with ASP.NET Framework hosted on IIS, or it could involve a rewrite and porting it to ASP.NET Core hosting on Linux, thus saving licensing costs for the Windows OS. Again, another option would be to replatform and rewrite to Amazon EKS, which is the Kubernetes orchestration approach, and that would be similar in the sense it would be replatformed on ASP.NET Framework hosted on IIS within a Windows container, or it could be a rewrite to ASP.NET Core hosted on Linux using the porting tool that is available from AWS. Next option would be more challenging, which would be a rewrite, where you could host on AWS Fargate, and this would give you a target technology of ASP.NET Core hosted on Linux, where you would have ported the legacy .NET framework onto .NET Core. Again, the final option would be to basically go with serverless, which is AWS Lambda, and that would then entail porting it to ASP.NET Core hosted in a Lambda environment. So let's recap some of the migration options. For example, bring your servers. In this case, AFDS have completed this journey. They leveraged Cloud Endure Agent on-prem. They then performed the replication. They tagged their AMIs according to how they would sit within AWS, and then deployed using AWS CloudFormation or Cloud Endure if they went the whole Cloud Endure route. Alternatively, if you have made the container journey, you could bring that, or you could just bring your code. In that case, you would leverage AWS App2Container. You would then use AWS ECR for storing your images, which is the Amazon Container Registry. You could then deploy using a combination of CloudFormation for infrastructure and DevOps for deploying your containers. Finally, you can use approaches like blue-green deployments to get your code into production. And finally, bring your functional specs. That would then mean leveraging AWS Lambda. That would entail if you were using legacy .NET Framework to port to .NET Core, you would then select the AWS Lambda and API Gateway, which would then involve refactor and deploy using SAM. From the left to right, you can see which option is simple, going to the right becoming more complex. So bring your servers is what we typically call a rehost. Bringing your existing containers or code would be a replatform. And porting to .NET Core would be typically called a refactor. Let's talk about .NET application migration strategies. So, for example, deploying your existing .NET Framework apps as is to EC2. For example, every app can have custom server configurations, different .NET Framework versions, and IIS configurations and dependencies. And that would be moving your code as is into a VM or EC2. Next would be to containerize into Windows Container, which would mean that you would not port to .NET Core but leave your existing framework in place and leverage Windows containers and orchestrate with AWS ECS, our container service. Again, this supports different legacy .NET frameworks, IIS configurations, and underlying dependencies, and also can reduce your licensing costs by only charging for the host for the container orchestration. Next, you could then use the AWS porting tool and port to .NET Core and run in either ECS or EKS, the Kubernetes orchestration framework, or Fargate, and run as Linux containers. In this case, there are no OS licensing costs, and you would result in smaller containers having moved to Lambda versus Windows containers. Finally, you can port to .NET Core and run as serverless in Lambda. So from going from top to bottom, you can see the first option is easier with more challenge and more level of effort as you move down to serverless and porting to .NET Core. So the question now is, when should you refactor? When the original product was way off the mark, didn't achieve goals, i.e. there was no user adoption. the original product does not have traction, there has been significant deviation from the original intent of the product, or you are going after a new market share. Technology is holding you back. Mainframe. Visual Basic is overtly customized using things like SFDC or AEM. Or you wish to redefine the business process around your new system. We will now talk about breaking the monolith, and in this case, AFDS OneVision platform. A typical monolithic or distributed monolith is effectively a monolithic architecture spread over multiple machines, or an architecture which needs to be deployed with other services due to coupling. A distributed monolith is a system that consists of multiple services, but for whatever reason the entire system has to be deployed together. This is the case with AFDS OneVision platform, which we are modernizing. Here, the account, inventory, and shopping service need to be deployed together due to their tight coupling. A distributed monolith may well meet the definition of a service-oriented architecture, but too often fails to deliver on the promise of SOA. Distributed monoliths have all the disadvantages of a distributed system and the disadvantages of a single process monolith without having enough upsides of either. So let's talk about what it means to break the monolith for Acme Financial Data Services and why they're looking at this. AFDS have a tremendous amount of resources invested in their existing monolithic application. AFDS are looking for a sane way to capture the benefits of containers and orchestration without having to completely rewrite. AWS provides a path forward for microservices based on apps in the future with the various services that they have, as well as AWS provides familiarity and a microservice proving ground with the many years in this space. Now let's look at breaking the monolith using something which is called the Strangler Fig pattern. The Strangler Fig is a form of vine which comes from the natural growth around the host tree. Gradually, roots wrap around the host tree, widen and slowly form a lattice work that surrounds the trunk's host. As you can see here, in red is the Strangler Fig and brown is the original host tree. We can now think of the vine as a modernization effort and the host tree as a legacy monolith. Eventually the host tree is replaced, leaving the fig with a hollow trunk. Now let's look at this from a modernization perspective. This modernization method is based on incrementally replacing existing functionalities of the old legacy system with new applications and services in a phased approach until the new application eventually replaces all or the old part of the legacy system's features. So for example here, as we introduce microservices in the form of a fig vine, and we introduce more of them, i.e. for example, we replace more of the legacy monolith with more microservices, we can then strangle the host tree to the point where eventually the monolithic application has been fully replaced by microservices. Strangling means incrementally replacing functionality in an app with something better, therefore cheaper, faster, and easier to maintain. So what we have here is a typical three-tier architecture with a UI, the original monolith, and a database to service a data store. As functions are replaced, dead parts of the monolith can be removed or retired. So as you can see here, by inserting a proxy between the UI and the original monolithic code, you can then call out to the service. What is also shown here is a portion of the database has also been extracted and made into a dedicated data store for this new service. This includes new functionality during strangulation to make it more attractive to business stakeholders. So this is the continuation of strangling the monolith for another service and another dedicated data store. Therefore, if you continue this process, you will eventually remove the original monolith or have it down to a point where it only features functionality which no longer needs to be replaced. Now let's discuss when to use the strangler pattern. The following guidance will ensure that you don't have to redeploy the entire monolith application regularly, and by breaking services out, it will allow you to independently scale and deploy the application more smoothly. First, select a component which has good test coverage and less technical debt associated with it. Starting with this component can give teams a lot of confidence during the modernization process. Next, select components which have scalability requirements. Start with one of these components. Finally, select a component which has frequent business requirement changes and more frequent deployments. Now let's go back to the AFDS OneVision platform, which we discussed earlier, and the services we identified as possible candidates to strangle from the monolith. And now we will discuss how we will do this by leveraging branch by abstraction. Branch by abstraction is a technique for making a large-scale change to a software system in a gradual way that allows you to release the system regularly while the change is still in progress. So here we have the account service, the invoicing service, and inventory service we identified as having loose coupling and high cohesion and good candidates for modernization. Now let's walk through the process of branch by abstraction. First, we will introduce an anti-corruption layer in the form of an interface. This will create an abstraction point for us. We will introduce it between the invoicing and inventory service and the account and inventory service. Then we will remove existing calls from the invoicing to the inventory service as well as the account and inventory service, and we will work on a new service implementation. The service implementation is effectively client code inside the monolith that will allow calls out to a new microservice. This service implementation will implement the same service. The functionality inside the inventory service will be copied into the new inventory microservice if there's no need to change the legacy code. We will implement the switchover by pushing all this, including the new interface, the service implementation, and the new inventory service, first into QA for testing, the service implementation and the new inventory service via the existing monolith, and finally into production for full evaluation. Once we are happy with the stability and performance of the new inventory service, we can perform a cleanup. This can involve cleaning the monolith by removing the legacy inventory service. So now let's look at strangling the monolith at scale. This example shows how you can implement a new service, including its own dedicated data store, while ensuring you can still communicate with the monolith by the use of an anti-corruption layer. So as we discussed before, we isolate the different subsystems by placing anti-corruption layer between them. This layer translates communication between the two systems, allowing one system to remain unchanged while avoiding a compromise in its design and technological approach. So as we break out more services, in this case the user service, and introduce an anti-corruption layer, we can also have the user service have its own dedicated user database. Again, we can do this for the cart service and introduce an anti-corruption layer, and then also have its dedicated data store. Likewise, for the account service, the introduction of an anti-corruption layer and a dedicated account database. So as you can see here, not only are we strangling the monolithic application, but potentially strangling the monolithic database by introducing dedicated data stores for each microservice. So finally, as you can see here, as we continue to break off microservices from monolithic application, including creating a dedicated data store for each of the microservices, we can eventually eliminate the monolith altogether and the monolithic database that supported it. We will now delve into leveraging the principles of domain-driven design to guide the process of breaking the monolith and the use of the strangler pattern. Domain-driven design. Domain-driven design is an approach to developing software for complex needs by deeply connecting the implementation of an evolving model of the core business concepts. Its premise is place the project's primary focus on the core domain and domain logic. Base complex designs on a model. Since we already have a complete application in place, we need to work backwards from the monolith. It is via this premise we will leverage the strangler pattern to guide the breaking of the monolith and arrive at which services to strangle, hence the term domain-driven strangler. Strangling the monolith. Follow the data. In some cases, we may have a legacy application with unclear, hidden, and hard-to-follow dependencies. It is therefore not clear what the impact of strangling certain services will have on the other remaining services and the monolith as a whole. By following and collecting the data in the running application, we can better form an understanding of the dependencies, coupling and cohesion, and achieve independent deployability for the services we plan to strangle. So as you can see here, we need to study the traffic around the system. Therefore, by following and collecting the data in the running application, we can better form an understanding of dependencies, coupling and cohesion, and achieve independent deployabilities for the services we plan to strangle. Distributed tracing. Modern applications and sites increasingly use many interconnected services. An application architecture that relies on many services or microservices is often referred to as a distributed system. Distributed tracing is a process of tracking the activity resulting from a request to an application. So what do you need to discover? Trace the path of the request as it travels across the complex system. Discover the latency of the components along that path, and know which components in the path is creating a bottleneck. Let's use this example as a typical multi-tier web application within an AWS VPC and two availability zones. At present, the user accesses the system via an Elastic Load Balancer. We will introduce a pass-through proxy by adding an API gateway between the users and Elastic Load Balancer to trace and record requests to the application. We can then leverage AWS X-Ray to trace and study the requests being passed into API gateway. AWS X-Ray traces user requests as they travel through your entire system. It aggregates the data generated by individual services and resources that make up your application, providing you an end-to-end view of how your application is performing. This shows a service map. AWS X-Ray creates a map of your services used by your application with trace data that you can use to drill into specific services or issues. This provides a view of connections between services in your application and aggregated data for each service, including average latency and failure rates. You can create dependency trees, perform cross-availability zone or region called detections, and more. We will study latency and performance issues and areas for improvement. We can see the details of each service. So to recap, by using distributed tracing, we can make more informed decisions about the possible dependencies of underlying services and the potential difficulty of strangling them out of the monolith. So to recap, we evaluated these services and plotted them onto our chart. We then established that these core services are good candidates for modernization. Now that we have strangled our new service, we need to think about DevOps and a suitable deployment model which will cause minimal business impact. Here are two DevOps deployment approaches. Blue-green is immediate switching to the new service. Here you are confident the new service can be fully released to production and will cause no impact to the business. On the other hand, if you wish to do a phased deployment, you can consider a canary release and leverage API gateway to channel at most 10% of the calls to the new service to evaluate it under a lower load and increase traffic over time, while keeping a close eye on its performance. If you notice any performance degradation, you can reconfigure API gateway to return 100% of the load back to the legacy system. Canary release. So in a canary deployment, you send a small percentage of requests to your new application as a way of testing it without exposing the majority of your users to this new and untested application. If the app performs well, you can continue to increase the percentage of requests that it receives until finally you have promoted it to receive 100% of the requests. Here we are leveraging a canary release of the new inventory microservice in the form of a Lambda function. We increase 10% of the traffic to the new service every hour while keeping a close eye on performance. We can invoke additional Lambda functions as we increase traffic. We are also leveraging the AWS data migration service to pass inventory-specific data to the inventory microservice dedicated data store, which is now DynamoDB in real time. In this video, we talked extensively about breaking the monolith and how to migrate your .NET applications. I would also like to highlight a couple of other very important videos in the series. The next one being part 3, which is serverless and container .NET best practices. Here you will learn how to build modern architectures with AWS Lambda, Amazon API Gateway, AWS Fargate, and Amplify around .NET and serverless. A later video you should definitely consider watching is part 6, Modernized DevOps and Serverless and Container Pipelines. Here you will learn how to establish a continuous DevOps CI/CD pipeline to build, test, and deploy the .NET Core services you strangled here. An area we touched on but never dived into very deeply is another monolith, and that is the centralized database. The challenge of strangling the monolith database is also a very major challenge to achieving lesser coupling and higher cohesion. Seldom one database fits the needs of multiple distinct use cases. The days of one-size-fits-all monolith databases are behind us, and the developers are now building highly distributed applications using a multitude of business databases. This is a quote from Werner Vogels, CTO to Amazon.com. AWS offers many services which offer an alternative to storing your strangled data, and also to best fit the data type which will be used by the new strangled service. Careful evaluation of the nature of the data being stored might help you select the best fit from available AWS data store services. So in relation to this, I also recommend part 4, Migrate and Modernize Database Workloads. Here you will learn how to strangle the data stores for the new microservices you did here. We will look at examples found within Acme Financial Data Services and explain the migration/modernization journey around customer examples. In part 5, around data lakes, a final leg of the modernization journey can be the creation of a data lake. Data lake is a centralized, curated, and secured repository that stores all your data, both in its original raw form and then a processed form for analysis. A data lake enables you to break down the data silos and combine different types of analytics to gain insights and better business decisions. Using it in combination with ETL and other data transformation services, it serves as a powerful offering to feed into data silos leveraged by independently deployable microservices. So So now brings this video to an end, and I hope it was useful and provided food for thought on your modernization efforts.